So, good morning. We are here with the Dr. Molina. Nice to meet you, Doctor. And we're going to talk about the black holes. The Dr. Molina is an expert in this topic, and we're going to ask some information. So, my first question, Doctor, is in your own definition, what is a black hole?
Okay, thank you. In my own definition, I don't know what black holes are, but I know that those physical objects come from as a consequence of the solution of the Einstein's equations, and they are interpreted as a singularity in the space and time. That means that we cannot describe these objects in term of physics, because singularity stands for something that we don't know. But what we know about them is that space and time do not behave the usual way inside these objects.
Okay. And do you know how big can a black hole be?
I don't know how big they can. They could be as big as big as they have mass, because its height depends on the amount of matter they have inside. And as I recently told you, these objects are singularities, which what means that even light cannot escape from them. So the whole surroundings of these black holes goes inside them. So they are getting bigger and bigger and bigger as long as they have matter to eat, let's call it.
They can like form bigger than the sun, for example, or
For sure, the sun is like a very tiny grain of sand if compared with the black hole that is inside or in the center of our galaxy.
Okay, and do you know how black holes are formed?
Yes, as I told you,
Only
black holes are just the result of some amount or big amount of matter inside a very tiny space. It's like you're trying to put here the whole matter in Zamorano inside this book. What is the quantity that relates this? Is density, right? Is mass over this space or volume. So you have a very big density. If you reduce this volume to this, you will expect that the amount that will increase their value is the density, right? If you continue reducing this value, and you want to put all your matter inside this little box, you will have a very big density, right? If you continue reducing your space, you will have an infinite density. And when this happens, we say that this star or this big stellar body reaches its Schwarzschild radii. And when this happens, this star or white dwarf, or I don't know how it's called, changes or becomes a black hole.
Okay, and I was reading about wormholes, and do you think that black holes and wormholes are the same thing or are different?
They are, but different interpretations of the same equation. I don't remember, but I used to have this in this Blackboard, the equations relating a singularity inside a black hole and a wormhole. And this was a theory I was developing last days, last month. I deleted it. But if you connect the singularity inside a black hole with a wormhole, you can or you could travel to another spaces, another universes, or you could create another universe. This it's a shame I deleted this this theory, but I think I have some screenshot or some pictures I could send you to you to see that they are the same things, but if we connect these two ideas in one idea, you could travel
like
to
a
another
portal.
universe. Exactly, you transport. But black hole is the representation of the formation of space and time, and wormholes are the practical uses of this black hole, or technical, or how could you use or benefit from this phenomenon to travel in space and time. So you could travel very big distances in a very tiny amount of time. It's quite interesting, this idea. It's called, I'm sorry, this is called the Einstein-Podolsky-Rosen theory. And it's traduced or translated as wormholes.
This is a theory.
Yeah, and I have my own theory in which we connect an Einstein-Podolsky bridge with an Einstein-Podolsky-Rosen bridge, and you can connect this. It's quite interesting also.
Okay. And what happens if we enter in a black hole? We can resist that.
No, we can't.
We can't.
We can't, because nothing can escape from black hole. Nothing, even the light cannot escape from black holes. If you, I don't know if you have seen this this image from this recent image from sound.
Yes.
From the black hole. This is not the black hole itself. This is only the absence of the black hole, or what is supposed to be there. You have nothing. You only have this ring, this black ring, right? It's not the black hole. This is just the evidence that even light cannot escape from this black hole. So what we are watching or seeing in this picture is the absence of light, and that is interpreted as the presence of the black hole. It is very very interesting and puzzling, but it's very good, very nice.
And do black holes emit anything, radiation, for example?
Yes, they emit the Hawking's radiation.
Hawking's radiation.
He proved that black hole do not only absorb the matter outside in the universe, but they also emit this Hawking radiation in order to maintain an equilibrium in the universe, because physics law cannot be violated. So in order to maintain the lepton number or the particle number in the universe, they must emit this particle and anti-particle.
And for example, also emit energy. Do you think that we can use this for energy source?
For sure. I also have a theory or an idea about this. Indeed, this is from since some 10 or 12 years ago. I have this idea about creating a very tiny black hole, a portable black hole that you can put in your bag or in your car, and you can have energy for the whole country. You could fill
with
the whole country with just a very tiny black hole, a portable black hole that you take with you for for a weekend. But this energy will be almost infinite.
Yeah.
Because they do not only spin around some axis, but they also emit this radiation, and if you could in some I don't know, in some way to store this energy, or to use this spinning energy, you could use it.
Yes. Can be possible.
To solve our country issues,
Yeah.
energetic issues.
Yes. Okay. And so, will our universe can become a black hole in the future? It exists like a theory that they are prognostic this.
Indeed, our universe comes from a singularity, like the one inside a black hole. Stephen Hawking shown that the one of the main work of Stephen Hawking was this about he proved that the Big Bang, where our universe comes from, the Big Bang, the singularity from our Big Bang, from which our Big Bang comes, is like the one existing inside a black hole. So, as I told you some minutes ago, I took this idea and started to prove that we could produce another universe just connecting the dots, as some people will say, but just connecting a singularity inside a big black hole with a wormhole, and you could go through a black hole and emerge in another universe, or you could put a particle inside a black hole, and this particle becomes single, passes through the singularity and emerges as a new universe in another dimension. Like, or another particle could go through this, or back in time through this singularity, and emerge here as a new universe, as our universe. Indeed.
Yes. And the last question, do you know the difference about the black hole and a white hole?
Yeah, this is just it's a theory in which in which this singularity goes back in time or in front, or for the future. In the same example I put you with the universe coming from another dimension, emerging from this. In this sense, this black hole will emit matter and light and energy, and in the sense from our universe to another universe, our this black hole absorbs matter and energy.
Okay. So thank you very much, Doctor, for the information.
Okay, so beware with black holes. They are very
very interesting topic, and
difficult, very hard to escape from them.
To describe and to understand.
But try to not to get inside of this black hole. It's very hard. I don't know.
Okay.
Our insurance did not cover this.
So
excellent.
Thank you for all. This was the interview, and thank you.
Okay.